Okay, hello. Good evening, everyone, and welcome to our meetup, Data Visualization Zurich, number 19. And today we will talk about data visualization, intermediate principles, and we have with us Seka. So thank you very much for being with us. First, just a few words about our meetup. So my name is Luc. I'm an interaction engineer at Interactive Things. Interactive Things, the design studio here in Zurich, Switzerland. And I co-organized this meetup with Benjamin Wiederkehr. Benjamin Wiederkehr is managing director at Interactive Things. And we organized this meetup to foster a community of data visualization practitioners here in Zurich and everywhere in the world. And we hope to create a space where we can share and advance knowledge of about data visualization and to create collaboration and relationships between us. So if you are interested in participating to our meetup in any way, if you want to speak about your work, to talk about your work, to speak about a topic, don't hesitate to reach out to us, to me and Benjamin, either on meetup.com/dataviz-Zurich or on Twitter and Instagram at datavizZRH, which stands for Zurich. And you can also drop us an email at hello@interactivethings.com. So about today's session, so we have the pleasure to have with us Seka, who will give us a presentation for about 40 minutes. And we will reserve some time at the end for questions and answers. But you can also ask questions at any time, and we will try to keep an eye on it. And Seka maybe will take some time during the presentation to answer the questions. So really don't hesitate to ask questions. And to do that, you can use the button Q&A just below the video feed. And there, so we can keep track of all the questions. And don't hesitate also to participate in the chat and to give us feedback or anything. So today, so we have the pleasure to have with us Seka. So thank you so much for being with us. So Seka is a freelance data scientist at Allcause.com and also at the Swiss Data Science Center. And also instructor of the data visualization module at Propulsion Academy. And today's session will be about intermediate principles of data visualization. And it's intermediate because it's actually a follow-up of a previous meetup that Seka gave already in October 2019. So it's actually a while ago, at the time where we were still doing the meetups in our studio in Zurich. And at the time, we talked about really fundamental principles like marks and scales and colors and how to create color palettes and things like this. So today it's a follow-up, but I think it's okay if you were not there during the first one. You will learn something in any case. And we will talk more about how to give context to data visualization to really create a data story and an expressive data story. So without more comments, I will give you the stage, Seka, and I will stop sharing my screen so that you can share yours.
Okay, great. Yeah, thanks for that introduction, Luc. And wait. Let me share my screen now. There we go. Okay, so hopefully you see my screen.
Awesome, yeah.
Great. And let me get started. So yeah, thanks again for the introduction. So as Luc mentioned, my name is Chandrasekhar Ramakrishnan, and I'm here to talk about telling stories with data today. So also as mentioned, today's presentation follows one that I gave in 2019. And these two together create a short two-part introduction to the basics of data visualization. In the first part, we developed a framework for thinking about visualizations. And we looked at some ideas and tools that can help us build a solid foundation for approaching visualizations. And today we're going to look at techniques for telling stories with data. You should be able to follow today's presentation, even if you weren't at the last one. And all my materials are available on GitHub. The link has already been made available on the meetup page and through some other channels. And so if you want to see what was covered there, you can check that out. All right, if I go advance. Okay. Right, so where are we? Yeah, okay, great. So let me start with a little bit about me. Again, repeating what Luke already mentioned. So I work part-time at the Swiss Data Science Center, and I'm also a freelance data scientist, and I teach the data visualization module at the Propulsion Academy Data Science Bootcamp. On the left there's some ways to contact me. My handle's @CIR at both GitHub and Twitter, and feel free to get in touch if you wish to do so. So in part one of these presentations, we looked at a framework for thinking about visualizations. And in particular, we looked at how to use color in visualizations and how transformations of the data can be helpful for achieving a clear presentation. Today, we're going to look at techniques for making visualizations that tell a story with data. So what I'm going to present today is largely independent from part one, but let me go over a few definitions so that we can ensure that we're all on the same page with regards to terminology and also attitudes towards data visualization. So we started in that first part with identifying a goal for data visualization, which we defined as enabling quantitative reasoning with your eyes. So this is by no means the only way to approach data visualization, but it is the one that kind of informs how I tackle the subject. And I like this definition because it emphasizes things that are important to me about data visualization. First of all, that it has to do with quantitative data. And as a result, it has to respect the properties and characteristics of this kind of data. And second, that has to do with the eyes. So it must be at least aware of like the characteristics and the strengths and the weaknesses of the human visual processing system. And having a goal like this in mind, to me at least, makes it easier to make choices when constructing a visualization, especially when we're constructed with multiple options. It gives us kind of something to hold on to when we need to make a decision. And not to kind of belabor this point, but I just want to make clear that not all presentations of data try to achieve this goal. And I like to distinguish between data visualizations and infographics. So this terminology isn't standard, but it's just kind of how I talk about these things. Data visualizations that we'll talk about today present data to enable quantitative reasoning with your eyes. And you see some examples of that on your left over here. So infographics, like what you see on the right, also present data, but they do so in a way that doesn't emphasize quantitative reasoning. The graphics on the right, they're certainly also based in data, and I think they're really great illustrations of certain ideas, but because they have a different approach, they're just not the sort of thing that we're going to talk about today. So let's give you a bit more terminology now. So here's the vocabulary that I use to talk about the different parts of visualization. So the core of a visualization are the marks that represent the data that we're showing. But to understand the data, some context is necessary. And the next layer of a visualization provides this context that's there for interpreting the marks. So the primary layers of this context are the axis labels that you see here for the X and the Y axis. The tick marks that kind of give you an orientation in the space of those axes. The tick labels that kind of assign a label to those tick marks. Title, which describes what we're looking at in the visualization. and a legend, kind of, which might indicate what the marks show, and especially distinguish between different kinds of marks if there's more than one that's in the visualization. So those are the primary layers of context that are present in pretty much every visualization that you'll see. And they're there because they're really necessary for the basic orientation in the graphic. But there are further layers of context which are not present in every visualization, but they are there in visualizations that tell a story. And so this is what I'm going to call the storytelling context. And today we're going to be taking a look at how this context works. So the materials I'm presenting today draw extensively from Edward Tufte's first two books, The Visual Display of Quantitative Information and Envisioning Information. So if you're not already familiar with them, I definitely recommend these books for going deeper into these topics. So Tufte argues that quantitative reasoning and therefore data visualization is largely motivated by the goal of making comparisons possible. So quantitative reasoning is about comparison, but how do you make comparisons possible? You do this by presenting data in context. And this is achieved through layering of information and increasing the density of the data. So there's certainly some tension between density and clarity. As we have more data, it becomes easy to kind of lose the forest for the trees and just get lost in the marks that you're looking at and kind of lose the bigger picture. And highlighting is a way that we can present high data density graphics and still kind of give the viewer signposts to guide them to the relevant information. And we're going to look at how to use color, transparency, and text to achieve this. Plots from Fred, which is a tool for exploring economic data, always shade in periods of recession, which you see here shaded in gray or yellow. And they do that because many economic variables behave differently when the economy is contracting. So for example, this is a plot of personal consumption expenditures. And an economy being in recession is one obvious reason why people might be spending less. Without that recession context, the behavior of the time series seems kind of unmotivated. But with the context, it's basically obvious what's going on and that connection to what's happening. So let's dissect this plot a little more. Sorry. Yeah, okay, let's dissect this plot a little more to see what's going on there. So on the face of it, it looks like a plot of two variables. We have the year-over-year change on personal consumption expenditures on the y-axis and time on the x-axis. But there is in fact another variable of data necessary to make this chart, which is the change in GDP. We just don't see it in its full fidelity. And it's actually not even necessary to see it because we only really care about whether the variable is below 0 or not. If it's below 0, we mark that region in gray to indicate a recession that happened in the past, or in yellow to indicate a recession that's currently ongoing. Many of the techniques that we're going to look at share this kind of property, that they incorporate additional data variables that are not and do not actually need to be reproduced in full. So using text is another way of layering information. This plot is taken from an article about basketball and illustrates how teams in the semifinals of the 2014-2015 playoffs all took advantage of the three-point shot. So this is a plot of three variables. On the x-axis, you have 3-point attempts per 100 possessions. On the y-axis, you have 3-point percentage. Both of these are quantitative variables. And then there's a third variable, which is the team name, or I guess just the team, a designation of the team. And that's a nominal variable. that you see for 6 teams. You don't see it for all of them. But you don't need to know what all of those teams are, because we don't actually not interested in most of them. We only need it for the few teams that are necessary for contextualizing the information. Here's another plot from that same article, which is focusing on a basketball player named Curry. To explain his skill, the plot shows how he compares to the league in general and to the best players of the league in particular. And it does this through high data density by layering multiple variables. There's 4 variables in this plot. So you have total shots on the x-axis, expected points added on the y-axis, the size of the marks indicate the number of shots taken per game by that player, and then you have the name of the player there. And you don't see the name for every single player for the reasons that we already kind of talked about. And that use of name there is used to highlight and draw your attention to just a handful of players that you really want to compare to one another. So to achieve this high data density that we have here, transparency is used, which makes it possible for many dots to overlap, but still be distinct. Text labels and color are used to highlight a small number of players that we might want to look at in great detail. Yeah, we're not really interested in every single player in the league. We really want to just compare Curry to his cohort of players that are comparable on these statistics. And we have the names of those players indicated as well. So we can see where Curry falls in relation to those other players in the space of the data on this plot. Let me take a brief aside for a second to talk about transparency. So how do we control transparency in a computer-based kind of graphics context? We do that using alpha, or the alpha channel. So what you see here is a pattern that's made with circles, and it's the same pattern in all of the graphics that you see. But by varying transparency, that pattern can appear as like either a solid blob, which is what you see when alpha is equal to 1, or a pattern that's made up of individual circles that are distinct, which becomes clearer and clearer as alpha goes down towards 0. And so, yeah, now let's take another look at another way that we can use layering to our advantage when presenting a data visualization that's trying to explain something. So data that's layered over a basic plot can either all come from the same data source, or it can come from a secondary data source, or it can be synthetic, that is computed using other data. So that's what we see here in this example of layering used to show data with a model layered on top of it. In this case, the model is a regression model of shooting efficiency versus shooting volume for a large number of football players. Which makes it possible to compare true extraordinary players, Messi and Ronaldo, against one another and kind of against the model which extrapolates the behavior of all of the football players into the regions that these two extraordinary players kind of inhabit. Before I continue, maybe I can just kind of quickly ask if there's any questions. It's hard for me to keep an eye on all of these channels at the same time, but if anyone has any questions, I can try to respond to them really quickly. Just taking a brief look at the chat. Okay, don't see any questions.
So far, no question.
Okay, yeah, then I'll continue. All right. Okay, here we are. Next. So let's spend a bit more time with this aspect of data density and how that kind of interacts with visualizations. So viewing as much data as possible is really key to proper interpretation and robust understanding. Cherry picking a subset of the data is kind of an easy way to get misled. And this might be done intentionally, or it could be done even unintentionally. So consider this example that's drawn from economics, where there's a concept that's called the Phillips Curve, which posits that there's an inverse relationship between the unemployment rate, which you see here on the x-axis, and the inflation rate, which is shown here on the y-axis. So what the Phillips curve states is that as the unemployment rate declines, the inflation rate should increase. And if we look at data from 8 years in the US between 1961 and 1969, that seems pretty plausible. The data fit the theory, in fact, almost suspiciously well. So as someone who consumes visualizations, you should always be skeptical when you see a small amount of data being presented. It's very easy to select a data subset that supports an argument while hiding the data that doesn't support that argument. And as a creator of visualizations, you should aim to show as much data as possible. Not only is it more honest, it's also more convincing. So if a conclusion holds when looking at all the data, it's going to be more robust. If we extend our view to 60 years worth of data covering the period from 1960 to 2020, we see a much more complex picture emerge, revealing periods where the US had high inflation and high unemployment. So for example, in the 1970s or the early 1980s, and also containing periods where there's low and decreasing unemployment combined with low inflation, which kind of calls this idea of the Phillips curve into question, at least with respect to the US. William Phillips identified the Phillips curve while studying unemployment and inflation in the United Kingdom. And maybe the US and the United Kingdom behave differently in this regard. How can we make a visualization that looks at a larger array of countries? One way we could do this is just to overlay multiple plots into one figure, as you see here. But as is pretty evident, it doesn't work so well for this kind of plot where there's a very high data density and the individual plot itself is pretty complex. When kind of two of these are overlaid on top of one figure, it makes it really difficult to distinguish one series from another. And motivated by that problem, how to retain high information density as we add variables, let's take a look at the technique that's called faceting. It goes by multiple names, but faceting is kind of the standard technical term for it. Here's the rest of that earlier excerpt from Tufte. At the heart of quantitative reasoning is a single question. Compared to what? Small multiple designs, multivariate and data bountiful, answer directly by visually enforcing comparisons of changes and of the differences among objects, of the scope of alternatives, and for a wide range of problems in data presentations. Small multiples are the best design solution. So Tufte calls this technique of faceting. He refers to it by the term small multiples. And he identifies it as being a generally good way to resolve the problem of showing many variables in high density plots. Let's take a look at some examples of this. So looking at that figure that we had earlier, to compare the relationship between unemployment and inflation in the US and the UK, we can do a small multiples plot. Each plot is individually a complex scatter plot showing the movement of the series through time, layering a model and orienting text, yet they remain readable even after the addition of a second data series. And if we wanted to kind of improve it even further, that wouldn't be too hard to do by importing it into Illustrator and kind of cleaning up the figure a little bit to make it look a little nicer. Notice here how the X and the Y axis cover the same range. So that's important when you make a plot that's kind of a faceted plot in order to ensure that the subplots are comparable to one another. There are cases where you can violate this, but you really should need to have a reason before you do that. And the default should be to use the same ranges for all of the plots. the faceted plot approach can be extended to a large number of multiples as well. We saw 2 earlier, and now we're looking at 9. Here's the Phillips curve plotted for 9 countries, giving a much more rich and nuanced view of the relationship between unemployment and inflation in many economies. So the relationship, while looking at this plot, we kind of get the impression that it broadly holds for 2 or 3 countries, so certainly Sweden and Japan. And if we wanted to be generous, we could maybe include Italy there. But it's not a very good description of what we see in the other 6. And in the UK in particular, the slope is going the opposite direction to what we would expect based on the Phillips curve. I also want to draw your attention to the fact that the facets here are sorted by R² from the regression. Generally, you'll find that some kind of sorting is necessary to make for both a visually calmer and kind of a more readable presentation of a faceted plot. So always consider the ordering that you apply to your facets. And when possible, use some salient or relevant variable or attribute of your data for sorting your plots. Okay, let me just quickly peek and see if there's any questions. See something there. Okay, yeah, great. Then let me continue with the next part, where we're going to do a case study. Where we're going to take this kind of catalog of techniques that we've been looking at. So we have layering, we have highlighting, we have faceting, and we're going to see how to apply them in practice. So Baptiste Guillemot is a sociologist in Paris who produced kind of over the last 12 months several really stunning visualizations of all-cause mortality in France over the period from initially 2001 to 2020, and he's extended them to include this current year, 2021. So the first one, I think, might have appeared on his blog or on Twitter, and he posts updated versions of them on occasion on his Twitter feed. And we're going to take that as the basis for a case study for applying these contextualization techniques. So we're going to use the same data that he made available. We're going to maybe incorporate some other data sources, and we're going to recreate versions of his plots to explore the potential design space that we have at our disposal with this data. And I certainly encourage you to take a look at his originals. They're really, really fantastic, and I have links to them in the GitHub repository. So for me, I think data visualizations should always be motivated by questions, since the question will guide design choices. So our question in this case is, are the effects of COVID in France visible in all-cause mortality data? So we're going to use data from the French Statistics Office, which has been kind of prepared and structured by Guillemot, and we're going to try to find traces of COVID in the all-cause mortality data. And as we create these visualizations, we're going to also try to follow these goals. We're going to see what we can do to let the data tell its story. And we're going to do that by providing the context and maybe some explanations to let it do that. We're going to focus on enabling quantitative reasoning with our eyes. And we're going to see what we can do to make comparisons possible and ensure that the comparisons are valid. So let's start with the real basic plot of the all-cause mortality data. So this is just a time series just plotted as a line plot. So this visualization doesn't really tell a story yet, but it gives us kind of a starting point to get oriented in the data. So we already had a question that we began with: can we see the effects of COVID in the all-cause mortality data? And when looking at this plot, there might be some further questions that arise that we'll also want to take into consideration when we kind of make our way towards the final visualization. So for me, there's some questions that immediately jump out. The first is that there's this clear upward trend, which starts kind of already around 2012, so quite a bit before the pandemic. Why is that? That's something that I think would need to be resolved as we make our visualizations. The next question is, well, where should I start looking for the effects of the pandemic? So there's a spike that's pretty clearly visible around early 2020, which I think, we can surmise this kind of occurred during the pandemic, maybe during the first wave. But where do I want to start looking like for signs of effects of the pandemic? And then the third thing is that looking at this plot, really the most striking feature is not in 2020 or 2021, but actually just a little bit before 2004. And what's going on there? And if maybe some of you who were alive then or remember that time well, might want to make an attempt to answer that question, please feel free to do so and post your responses in the chat. I'd be interested to see if anyone kind of immediately identifies why there's this huge spike in mortality in 2003. Okay, so for that, the first of those questions, an obvious place to look is within the demographics of France. So we can go to Wikipedia and find a kind of a table of population counts of France that cover the period 2020 to 2000 to 2020. And we see that the population of France increased by over 10% in that period. So this is just metropolitan France. Those numbers, they don't include like overseas areas like Martinique or New Caledonia or whatever. But it's good enough for our purposes to kind of get a handle on this data. And even just with that information, we'd assume if we were to assume that the base mortality rate stayed constant, we would expect a 10% increase in deaths in that time frame between 2000 and 2020, even without a pandemic. Since one of our goals is to ensure that comparisons are plausible and valid, we need to adjust for this increase in some way, because otherwise the effect that we see in our visualization could potentially have a cause that has absolutely nothing to do with the pandemic, which is what we're trying to focus on, but is just related to the pure demographic population increase that occurred in France in that time frame that we're looking at. So here's a second plot of that time series. But I've taken some data from Wikipedia to adjust the mortality converted to a rate of deaths per 100,000 inhabitants to adjust for the effects of the increase in population. So if you look at it, you see there might still be some other demographic effects. So another thing that could cause an increase in mortality rate would be an older population. And it wouldn't surprise me if the population of France in 2021 is kind of in aggregate older than the population in 2000. But already just kind of adjusting for the gross population does help kind of stabilize that series, which is good. And so that 2003 spike, I'll take a look later at the chat to see if anyone got this. It occurred in a year with a very, very bad summer heat wave. So I'm going to indicate that here in the plot with some text. And we're going to indicate the time frame of the pandemic, which I've defined as starting with the 10th COVID-19 death in France, using a different color mark. So we'll change the mark color to red to distinguish it from the pre-pandemic time series, which is in blue in this particular plot, so that it's more visible. So looking at this revised plot, kind of gives us some directions as to ways that we can make further improvements to this plot. So it looks like there are COVID effects that are visible here, but there's a clear seasonality in the time series. You see these kind of waves that go up and down, which are seasonal effects. And it makes it really difficult to precisely identify the COVID effects and if there's a spike there. And I mean, we see some spikes, but we don't really have a very good handle on them when looking at this plot. And it's partially because it doesn't make much sense to compare January and June, regardless of year, because mortality is typically lower in the warmer months. And the way we've plotted this data doesn't make it easy for our eyes to do that comparison and kind of just restrict comparing January to January and June to June. So with that in mind, let's make a new plot that makes it easier for us to compare similar points in time in the year over different years, focusing on that aspect of the data. One way we can do this is by making a plot where the x-axis covers 12 months rather than 20 years. So when we do this, it makes it natural for us to compare kind of on the vertical axis where we're looking at the same point in time in a year, or neighboring points which are drawn from nearby points in time in the year. And when we do this, we kind of start to see the outlines of a story that this data is presenting really starting to come through now. It's not yet really clarified, but it's starting to make its appearance. For example, we see clear evidence of a first and second wave of the pandemic in the data, but it also looks like there's kind of this mini wave that happens in summer of 2020 in France. But to be more certain about this, we need to incorporate some additional data that can kind of help us tease out the sources of mortality. We can kind of draw in a COVID-specific mortality time series and add that to this all-cause mortality time series here. Johns Hopkins University publishes a data set of COVID-19 mortality that we can use to add this context. And I've drawn that here in green. And we can, use the long-term, the median as an estimator of the base mortality rate at different points of time in the year. And we can add that together with to the number of COVID-19 deaths from the Johns Hopkins time series to get a picture of how much mortality is attributable to COVID. So with this methodology, we see that most of the deaths above the median in the spring of 2020 have COVID as their source. We also see that the summer 2020 increase in mortality isn't attributable to COVID because the COVID mortality rate is pretty low there. And the picture for the fall of 2020 is mixed. There are many COVID-19 deaths, but there's also many deaths that aren't attributable to COVID-19. So there must be some other source that's causing them. And it would be interesting and worthwhile to kind of understand what's going on there if we wanted to dig deeper into this data. And so now with this plot, I think we have the data that's necessary to better understand the situation. But the plot isn't doing a super great job of doing it, of presenting that always, because it's becoming visually a little bit busy and difficult to follow. And so here's a good point to turn to small multiples to see if that helps kind of make the plot visually communicate better. When we do that, we can get a plot that looks like this. So at its core, we have the data that we started with in the very first plot that we made. And we've added 2 additional data sources, French demographic data and COVID-19 mortality data, to allow us to get a better understanding of the behavior of these mortality series. And by combining these variables, we have a much richer context to make sense of what's happening. So in the first of these 3 faceted plots, we have basically the plot that we were looking at just before, which is the all-cause mortality per 100,000 inhabitants of France in the period of 2000 to 2021. And then in the second and third plot, we kind of have we zoom in, we focus on these 2 particular years, last year, 2020, and the current year that hasn't yet finished in its ongoing state. So in this plot, we kind of see some sections that require explanation that we want to highlight. We see the COVID-dominated first wave, which is the kind of first section of the middle plot there, where there's a high rate of COVID deaths. Then we see the second wave, which has, again, a high rate of COVID deaths, but it also has quite a few deaths that cannot be attributed to COVID. And then we have the second wave continuing into 2021, where it kind of stabilizes at a point where it looks like most of the deaths come from COVID. And in fact, we have a point there where it looks like COVID plus the median accounts for more deaths than we see in the all-cause mortality rate, which is also kind of an interesting phenomenon that might be worth discussing. And to help this visualization present its own story, let's add some explanatory text directly to the plot. And when we do that, here's what we get. So we have text that kind of highlights regions of interest. We also have kind of highlighting with an overlay to bring your attention to the region of interest. We have text providing explanations. Where it's possible, we have text that provokes questions. where we see phenomena that we can't really explain with the data, but we think are interesting and worth spending maybe some time, more effort to understand. And for some areas, we also quantify the numbers, and we present that to facilitate comparison, for example, between a virally caused pandemic wave and the devastation that's caused by a heat wave. And for comparison for your eyes, here's the original plot by Guillemot that we set out to duplicate. Ours is content-wise pretty similar, but there are some differences due to some different decisions that we made in terms of choices that we made for how we process the data and how we present it. But content-wise, they're pretty largely similar. And in the blog, he kind of explains how he made the plot, if I remember correctly. So now let me wrap up so we can enter into the question phase. What we've seen is that by showing data, overlaying information, and incorporating multiple data sources, it's possible to create a story that gives complex and nuanced insight into the effect of COVID-19 on mortality in France. We can see phenomena against an inherent kind of seasonality and between year variation that's inherent in the data. And we also see how much, but by no means all of the mortality in the 2020-2021 period can be attributed to COVID. We get a glimpse as well at the potential comparison to another looming catastrophe, which are warmer temperatures that could be a result of climate change. So kind of summarizing what we've learned, we have kind of this insight that context is the key to a visualization that tells a story. And then we have a few ways of incorporating and integrating context into visualization. We know that showing multiple variables is a way of providing context, and we can do that by layering them using color and text. We've also seen how highlighting can be used to provide context. We can do it with color and text as well, and we can apply it to draw attention of a viewer to the things that we think are relevant for the story that we want to tell. And we've seen how faceting is a technique that lets us show more of the data and provide context by just providing more data there. Here again is the URL for my GitHub repository that presents these materials. I have two Jupyter notebooks, one for part 1 and one for part 2, that contain the same content that I just presented. And it also includes the code there for running the examples. And there's a link that takes you to the same repository on a tool called Renku Lab, which is something I work on at the Swiss Data Science Center. And there you can also view the contents of the presentation, but you can also launch an interactive environment that lets you step through the notebook. So you don't need to kind of install Python and all the tools if you don't have them available. You can do that using the resources on the cloud. And my GitHub repository explains how you can do that. And if you want to execute the code samples or play around with it and understand how the visualizations are made, you can do it that way. So let me close with some advice again from Tufte from the epilogue of his first book. What is to be sought in designs for the display of information is the clear portrayal of complexity, not the complication of the simple. Rather, the task of the designer is to give visual access to the subtle and the difficult, that is, the revelation of the complex. So that concludes kind of my presentation-based part for today. And now I think we can turn over to the questions and bring in some interaction with the audience. Let me go and peek at the chat and see what's.
Yes, thank you. Thank you very much, Sika. It was really illuminating. I really liked how you extracted single elements from what I would generally describe as annotations. But the fact that you really singled out elements like this is really very interesting, I think, and your step-by-step case studies. But like really very compelling.
Yeah, and I see by looking at the chat that many
Yeah,
people actually knew what was happening in 2003.
2003. Yes.
Yeah, very interesting. So I see a couple of questions here in the QA.
Yes.
So let me start one. Sophia has a question. Do you discard data picking, intentional selection, and display of certain data points completely, or do you think it could be justified in some cases? Oh yeah. So I mean, that's a really good question, right? And absolutely, yeah. I mean, like if you have a large amount of data, then you will need to do some discarding of the data, because you can't show 20 million data points. It's going to look pretty messy probably in your plot. So there's a couple of things that you can do about this. One is to try to use a random sample, so to ensure that you're not introducing any bias, or maybe there might be another technique depending on the data that you're looking at. But you will need to kind of reduce that to a representative sample that's smaller. Also, if you're working with an interactive visualization, there's some techniques there that make it possible to kind of zoom in and zoom out. And there's tools like Bokeh I think there's a kind of a tool that's part of Bokeh called Data Shader as an example. I know the Python stack best. There's probably something similar in R, and there's very well something similar in like Tableau or something like that. I just don't know those tools as well. But they're you can use that kind of, they have built-in techniques that make it possible to zoom in and out of the data that allow you to see kind of an aggregate view when you're looking at high level, and zoom in to kind of see the individual plots when you're looking at low level. And I should also mention, in addition to sampling, like aggregation is also a very valid way of reducing the amount of data that you're doing. But you're not in that case discarding anything. You're just kind of making, you're clumping together data that's similar, that can be kind of considered similarly. But yeah, that's a super question. Yeah, I'm glad that you called me on that there. So there's another question here from Jonas, which is, what are your thoughts on achieving this in the world of mobile screens? Right. I mean, like, I guess mobile isn't so, it's a very heterogeneous world nowadays, because you have mobile screens like on, like there are these humongous iPhones and Android devices that like have a very high pixel density screens that you can actually do quite a bit on. And then there's also, of course, the kind of more like, like a 7 or 8 year old phone, which might not have the same capabilities as a modern screen. And so I think like a lot of these data visualizations, I mean, I generally, like if I'm looking at Twitter or Instagram, it's usually going to be on a phone. And there are people that do data visualizations, like these Guillemot ones. I think I initially saw them on Twitter. And they look fine there. Like it's still possible to use these techniques and do it in kind of a mobile friendly way, because you can just zoom into the visualization to look at the details if you want to look at something that might be small. But key for handling mobile is just making sure that your typeface is large enough so that you can kind of read the text if the text is necessary on a mobile screen. It also makes make sure that you export your visualization in a format that has high enough number of pixels that make it possible to zoom in and see those details, so you can still read it, so that the text doesn't become just like a smudge, but it's still legible. Yeah, let me think. And I guess there's the other like aspect, which maybe is implicit in what you're talking about, but which would be kind of interactive visualizations on mobile. But I think that's kind of a bit more of a thorny world, because just the way the devices you interact with the devices is quite different. So stuff like mouse over doesn't make sense or it's kind of, it needs to be implemented a little bit differently on a touch screen versus like a pointer-based kind of computer display.
I have a follow-up question about this, and because right now you mentioned interactivity, and I noticed that in your presentation, all your examples and advices were mostly about static visualizations, and
right.
yeah, you know, like most of the projects I do now at Interactive Things, very often we do application with a lot of data, and so we need interactivity and also animations to show the data, and very often it becomes a little bit more exploratory than explanatory. So I was wondering, like, if you have ideas about interactivity and also maybe animation, how they can be used to also tell a story.
Right. I mean, certainly that can be used to tell a story. It's kind of a very natural way of doing it. I mean, the super famous examples are this like Gapminder visualizations, for example, that use animation as a way of kind of showing how various variables kind of evolve through time. I think that's kind of, yeah, like a classic example of that.
Mm-hmm.
And those are definitely techniques that can be used here. It's not so much the focus of this presentation, because I think that's a topic in and of itself that really requires a presentation by itself. But at the same time, my attitude towards interactivity and animation is that, like, I think for the most part, good interactive visualizations have at their core good static visualizations. And you can use interactivity to make it possible to, for example, zoom into particular data or get more information about things or enable certain kind of navigation through data. But ideally, at its heart, there's probably a good static visualization that's the basis of that. I'm sure there are examples that violate that, but I think if you want to approach an interactive visualization, I would say start with focusing on the static visualization. And even these techniques, you can put text and stuff to help guiding the viewer through the data is equally important when working at interactive or an animated visualization. In animation, it happens kind of usually as a side effect of the animation, but in an interactive visualization, you need to have some, if you're just looking at like a bazillion data points, you have like kind of no idea what's really interesting. And I mean, I don't want to kind of bring up any examples to shame, to do any shaming, but certainly I'm sure everyone here has kind of come across interactive visualizations where it's just like, you have no idea what you're looking at, what you should be looking at, or what's interesting about the data. And those, I think, would really benefit from some of these highlighting techniques, maybe adding some text just to kind of explain, like, here's something interesting, go take a look at this, kind of explore this. Here are some things that you might want to do, and try to find out more about the data. But yeah, and I think, interactive visualizations by nature kind of have more of this like choose your own adventure type of experience to them, where you're really giving the user control. You're giving the user control of kind of going like how they want to navigate through the data. But it still doesn't absolve you, I think, as the creator of that, of the responsibility of kind of directing them in some way and incorporating your knowledge and experience with the data so that they have a more interesting experience of your visualization.
Do you have a plan to make a part 3 of these visualizations? What is missing in your
I would be happy
principles?
to do that, maybe in collaboration with some other people. I think that might be an interesting project. Maybe sometime this fall we could do that.
I would be looking forward to it.
Yeah. Any other questions here? I'm trying to keep my eye on this. No.
So we have a lot.
Maybe we could wrap up, and I mean, I think this would be a good time to advertise the next the next kind of this series, which I'm really excited about. Maybe you could say a little bit more about that.
Yes, definitely. So yes. So first of all, thank you so much, Sekar, for your presentation, and thank you everyone for contributing also. And yeah, our next meetup will be June 30, so the very end of June, and we will have Stephanie Posapek, who will talk about data visualizations for all ages. And she will talk about the book that she has published, which is called I Am a Book, I Am a Portal to the Universe, with Miriam Quick. Yeah, so it's a really great, I think it will be a great topic because it's, I think a book with data visualization and also physical visualization. And it's also the target audience is not only like us data visualization practitioners, but everyone, and also kids. So I think it will be like a really great meetup also. Yes, so yeah, I think we can wrap up. If you have more comments about and more questions, you can always reach out to us, Benjamin and I, about the meetup. So on Twitter and Instagram at DataVZRH, and also I'm sure to Sekar. I posted your Twitter handle earlier in the chat.
Great, yeah, thanks, and yeah, thanks everyone for listening.